Hi everyone. Today we will learn another application of derivative to find out maxima and minima of a function. So suppose a function fx is defined in its domain D and function behaves like this. You see, this is x axis and this is y axis. Like this, correct? So you just mark these important points A, B, C, D, E, F, G, H and I, correct? Now when you see function is monotonically increasing in section AB, correct? Similarly here it is decreasing, fx down. Similarly if you see in the section CD, it is again increasing, fx up. Then in DE again decreasing. Then if you see in EF, the EF may again function is increasing. Then FG may again decreasing, and so on. In this way, you can find out the function's monotonicity in various intervals. Now, if you carefully observe, in AB function is increasing, in BC function is decreasing. So one increasing and one decreasing. In between, the peak is the maxima. It is a maxima point, correct? And between one decreasing and one increasing section of the function, you get the minima point, correct? So there are so many maxima point here, this, and similarly these are maxima points. Similarly there are so many minima points, correct? And two more points are considered, that is initial point and that is final point, correct? So overall, this overall maxima means complete function's maxima will be this H point, that you call it as a global maxima. Okay? Similarly, if you see the global minima means C is downwards, na? So C, it will be global maxima. Global minima, sorry. Global minima. But you find out maxima and minima in this region. I am just intercepting this region. In this region. So in this region, only one maxima at point D and one minima at point C will get. In this region only. Only one maxima and only one minima. If such type of maxima and minima is calculated, we call it as a local maxima and local minima. Correct? So this is the concept. By checking the monotonicity of the function, we can find the maxima and minima of a function. So suppose here fx is defined in its domain D and function is behaving like this. Our function's plot is like this. So you see in different section. In AB section, function is increasing, monotonically increasing. Means what? F dash x is greater than 0. If you carefully observe in BC section, fx is monotonically decreasing, means f dash x is less than 0. In CD section, again function is monotonically increasing, means fx is upwards, and in that case f dash x is greater than 0. And similarly, if you see the DE case, again fx is downwards and f dash x is less than 0. What about point B? Exactly point B. From B to C, f dash x is less than 0. From A to B, f dash x is greater than 0. At point B, f dash x is equal to 0. Similarly, from C to D, f dash x is greater than 0. From D to E, f dash x is less than 0. What about point B? F dash x is equal to 0. Means these two maxima points, B and D, any maxima point can be obtained by putting f dash x is equal to 0. Similarly, for minima point, if you observe this C point, you just see this C point. From B to C, f dash x is less than 0. From C to D, f dash x is greater than 0. At point C, f dash x is equal to 0. Similarly, for point E also, f dash x is equal to 0. Means what? What is the conclusion? For maxima and minima point of function, what is the condition? You have to put f dash x is equal to 0 and you will get some values of x. Suppose you got value of x as a1, a2 and a3. So on this point x is equal to a1, x is equal to a2, x is equal to a3, the function will take either maximum value or minimum value. So conclusion is that between increasing and decreasing part of the function you will get maxima. Between decreasing and increasing part of the function you will get minima. There may be more than 2 maxima and there may be more than 2 minima. Now question arises, which point will be maxima point and which point will be minima point? So for checking this we have two methods. First method is double differentiation method. What double differentiation method tells? You calculate f double dash x, means double derivative. First you find out f dash x, then again f dash x can be differentiated with respect to x and you will get f double dash x. So the point means these points. In points by you will check the value of f double dash x. The point at which f double dash x is less than 0 means negative. This is maxima point. And the point at which f double dash x is greater than 0, that is minima point. Now in second method, what we will do, fx is a function, you find out f dash x and then you draw different intervals at which this function is altering its sign. So what I told, from increasing then decreasing you will get maxima. So this is the sign of f dash x. So positive is increasing then decreasing, this point will be maxima point. And from decreasing then increasing, this point will term as minima point. So that I have discussed in detail in my last video where I have discussed monotonicity of the function. So that way also, by assigning the sign, different sign intervals for f dash x, we can find which point correspond to maxima point and which point correspond to minima point. Okay. Now let us solve one example. Find the maxima and minima value of this function y is equal to x into x minus 1 ka whole square. In the domain 0 is less or equal to x, x is less or equal to 2. So what is the first step? Write down the function fx. So here fx function is x into x minus 1 ka whole square, and this is equal to x into x square plus 1 minus 2x, and this is equal to x cube plus x minus 2x square. Now what is the second step? Find out f dash x. So f dash x will be 3x square plus 1 minus 4x. Now for maxima and minima points, means value of x at which the function will take maxima or minima value, those value of x can be find out by putting f dash x is equal to 0. So what we will put? 3x square plus 1 minus 4x is equal to 0. And this gives 3x square minus 3x minus x plus 1 is equal to 0. And this implies that 3x minus 1 into x minus 1 is equal to 0. And this implies that x is equal to 1 and 1 by 3. So, two critical points you obtained. First is x equal to 1, second is x equal to 1 by 3. Now, we have to see at which point the function will take maximum value or minimum value. So, what is the step for that? There are two ways. First way is that find out f dash x, f double dash x. What is the value? F double dash x. F dash x is this value. F double dash x is 6x minus 4. Of what I have told? The point at which f double dash x is less than 0 means maxima. F double dash x is greater than 0 means minima. तो अब देखना पड़ेगा इन दोनों पॉइंट्स में से at which point the function is taking negative value and at which point the function is taking positive value. So at x is equal to 1, यदि यहाँ पे we will put x is equal to 1, you will get f double dash x is greater than 0, means it's a minimum point. It's a minimum point. And at x is equal to 1 by 3, so f double dash x is less than 0, means it is maxima point. Correct? So these are the points I got. Abhi the value, what is the maximum and minimum value in question it is asking? Maximum value के लिए क्या करना पड़ेगा? This point I will feed in the function. तो fx minimum, x is equal to 1 के corresponding function का minimum point है, तो fx minimum we will get. What is the value? Put x is equal to 1 in the function. तो 1 into 1 minus 1 का whole square and the value comes 0. Corresponding to x is equal to 1 by 3, you will get maxima point. Means fx maxima. यदि fx की maximum value निकालनी तो क्या what you will put? X is equal to 1 by 3. So you will get 1 by 3 into 1 by 3 minus 1 का whole square. And the value comes 1 by 3 into minus 2 by 3 का whole square मतलब 4 by 9. And this comes 4 by 27. So this is the value. But one thing also I told you, कि you have to check the function value at the end point also. So if two more points you will consider for checking, that is x is equal to 0 and x is equal to 2. At x is equal to 0, you will find fx is equal to 0. These are also as a critical points you will consider. Start point and end point also be checked for complete maxima and minima of the function. So at x is equal to 0, fx is equal to 0, and at x is equal to 2, you will get fx की value how much? 2 into 2 minus 1 का whole square, and this is equal to how much? 2. So you see there are 4 values corresponding to critical points: 0, 2, 4 by 27 and 0. So minimum value it is taking at both points, x equal to 0 and at x is equal to 1. And maximum value the function is not taking at x is equal to 1 by 3 but at x is equal to 2. So what is overall maxima? Overall maxima is value will be 2 and overall minima will be 0. So this is our answer. Now let us see if this equality is not given here. If this equality is not given here, then you need not to check the endpoints. Means 0 value also will not check, 2 value also we will not check. In that case, this 4 by 27 itself will be the maxima point and 0 is the minima point. So if such type of interval is there, then overall maxima will be how much? 4 by 27 and minima will be how much? 0. Now come to second question. Find the maxima and minima of the function fx is equal to x by 1 plus x square. D belongs to R. The first step is write down function fx, that is x by 1 plus x square. Second step, find out f dash x, and this value comes, this is 1 plus x square का whole square नीचे आ जाएगा, 1 plus x square d by dx of x minus x into d by dx of 1 plus x square, division formula, and this value comes 1 plus x square minus x, and here comes 2x, and divided by 1 plus x square ka whole square, and this is equal to how much? 1 minus x square divided by 1 plus x square ka whole square, and this is equal to 1 plus x into 1 minus x divided by 1 plus x square ka whole square. F dash x comes as a rational function. So if you refer my last video, I can easily plot the sign alteration of this f dash x when it comes in form of rational function. So you can refer my last video, there you can get the methodology. So correct critical points, what it will be? Critical points, this value will be x is equal to plus minus 1. Means you will plot like this, minus 1, 1, and these are the intervals. So at x greater than 1, f dash x, it will be negative because 1 minus x is there. And rest of the sign will alter, like this is minus, then this will plus, and this will be minus. So it's a very easy sign convention plotting of the f dash x. So now means what? Ki function is here, it is decreasing. Here it is increasing. Here again it is decreasing. Correct? So means function is decreasing, then again increasing, then again decreasing. So between one decreasing and increasing, there is a minima point. Means this point will be minima point. And between increasing to decreasing, you will get maxima point. Between increasing to decreasing, this point will be a maxima point. So क्या होगा? At x is equal to minus 1, you will get minima of the function. What is the function's value? Value will be fx is equal to minus 1 divided by 1 plus minus 1 ka whole square, and this is equal to minus half. And what is the maxima point? X is equal to 1 pe, you will get maxima. What is the value? Fx is equal to 1 by 1 plus 1 ka square, and this is equal to 1 by 2. So minima value is minus half, maxima value is 1 by 2. So this is also range of this function. So in this way, maxima minima concept use करके we can also find out the range of the function. Now you see here I have not used double differentiation method for finding maxima and minima. I only use the sign alteration method of f dash x to find maxima and minima, because double differentiation is little lengthy for this expression. We can do and we can find out also, but it will take more time. And this sign alteration method of f dash x, it is much easier to find out the maxima and minima point. So this is the way how we can find maxima and minima or range of a given function. So that's it for today. If you like this video, please give a like button and please subscribe my channel so that I can also get motivation to make more videos for you that may be helpful for you. Thank you.